A very good morning to you all, and welcome back to Dr. Vipin's Biotic and Bioinformatics classroom. And I'm sure you've gone through lectures 1 and 2 of the Python series. In lecture 1, we discussed how you can use Google Colab to start writing your programs without installing Python. So that is the advantage. At some point of time, we'll also install Python and also we'll use JupyterLab Notebook for running Python programs. But that will come later. For now, so that you don't have a mental block, we start directly with Google Colab. This is easy, simple, intuitive, and basically the learning curve is a lot easier. And once you get comfortable, we can go back and install Python and do it locally. Only thing you require when you work with Google Colab is an internet connection, which should be stable, right? So here you are. Let's start with today's work. So today we'll discuss string operations. I've already created a program for you that is called as string_functions.py. And we'll look into how this program tells you more about string functions in Python. So first, of course, let's declare a string. So we say a equals to, and in double quotes, Titanic. So when you say this, the value Titanic now comes into a. And if you remember, we can also check the type of the string. So let me just add a code here. So you say code, and you say print type, and again the arguments you give the a. So you can run this to check what is the data type in a. So when you press run here, it should give you an str or a string, right? So this is a string. We can also check whether it is actually string or not by using the isInstance function. So for example, is INSTANCE isInstance a comma str, right? So when you run this here, you should get a true statement. So you get a true. So which means that a is a string. So next we move on and we want to check the length of the string that is there in a. So the function that we can use in Python for checking the length of a string is the len function, len, right? And len takes an argument within round brackets. And then, of course, we want to also print the length. So we say length is equal to len a, and then we close this line by a semicolon. And within the same line, you can write print length, right? And in Python, it is not a problem. You could have mentioned an enter here, and you could also remove this here. That would still work for you. So this is 2 lines of code in Python. And if you play this now, you get the length of 7, right? So this is Titanic 1, 2, 3, 4, 5, 6, and 7, where the first letter is in uppercase and the rest of the letters are in lowercase. So now let's say you want to change the case of your string. So you want everything in uppercase or you want everything in lowercase, or else you want, let's say you have given in lowercase, but you want the first letter to be in the uppercase. So there are specific functions in Python to do such kind of modulations to your string. So first, of course, is the upper function. And the use of upper function is to basically convert all the letters in a string to a uppercase. And the syntax in which you can use it is, let's say you say UC for uppercase. UC is equal to a dot upper, and then I give 2 round brackets where I do not give anything. So this is the syntax for converting a string into an uppercase. You say UC is equal to a dot upper, and then of course I give a colon, and in the same line and then mention print, and the argument to print is UC, which is actually now carrying the string in the uppercase, right? When you run this here, you'll get a output where all letters of Titanic will be in uppercase. So you run this here, and here you are, you get Titanic, all letters in uppercase. Now, let's say you want all the letters in lowercase, like upper, you have a function called lower. And again, the way it is used is the same as you use upper. So you say LP is equal to a dot lower, and then you give round brackets without any arguments. And then again, we give a semicolon, and then we say print LC, right? And LC has to be within round brackets as an argument to print. When you run this here, you get your results again, where now Titanic, all the letters will be in lowercase. So here you are, you have all the letters in lowercase now. So now that we have all letters in lowercase, we want to convert only the first letter to uppercase. So for that, what we use is the function called title, right? And the way it is used is again the same as lower and upper. It's a title is equal to, and you can say LC dot title, and again, close your round brackets without any arguments. And then we could again print it in the same line by giving a colon, or you could basically remove the colon and press and enter. Now play this. You will get Titanic now with T capital, the way you had actually initially declared A, right? So T with capital and the remaining ones are in small letters. Let's say we have a more complex string. So we have a sentence, which is basically encoded in double quotes, right? Our sentences, all that remains is what remains, right? So this is more of an alliteration, the same word used twice in different contexts. So all that remains is what remains, and this is included in your double quotes. So this becomes a string, right? So this is your string, and you can again check whether it is a string or not by using the type function, or you can also use the isInstance function, and you can say that it is a string, and it should come to true if it is a string. If it is not a string, it will come as false. So let me show you that here. Go to code here and add code, and I say is INSTANCE. Then I give my argument. My argument is sentence, right? And then I say this is a, let's say I say this is a integer, int, right? So we are checking whether isInstance sentence is int or not. So when you play this now, you should get a false statement, right? So you get a false, which means it is not a integer. Then of course you could alter this. Let me say this is str and play this again. And now this time this should equate to true. So here you are, this is true, right? So which means this is a string. Then first thing, we want to calculate the length of the sentence. So we can directly say print, and in print, we give the entire statement len, and within the len, you give the argument sentence, right? So what happens here is first, the length of the sentence will be calculated. And because this is now the argument to print, this will be printed, right? So here you are, when you play this, you will get the value of 32. So you can calculate what is the number of letters here. And remember, spaces will also be counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Right? So this is the length of your string. So this is the length of your string, that is 32. Okay. All right. So now let's say you want to count how many times a particular word comes within your string. So for that, the command is count, right? And count again is used the same way as upper, lower, or title. You say print. And then again, you're giving the command within the print so that everything is processed in the single sentence and you don't have to use a additional variable name. You say print, and then in round brackets, you give sentence. And now you're counting the number of times remains comes within your string, right? So when you play this now, because remains is coming once here and another time here, right? So you run this and now you get a value of 2. So this is basically to count the number of times a particular word is coming within your string, right? Then let's say you want to count how many times A is coming within your string. So you can simply say again, print, and then you say sentence dot count, and then as an argument you give A within double quotes, close all the brackets, and then you say run, and this should give you the number of times A is coming. A comes 4 times within the sentence. If you look at this, this is the first time, the second time, the third time, and the fourth time, right? So this is how many times A is coming. Of course, because you've mentioned small a, so you get only small a count. Capital A will not be counted. So this count is case sensitive. So next, let's say we want to find how many times A comes after position 10, right? So we are looking at a substring that is beyond position 10, and we are defining the starting position from where we want to look into the string and see how many times A comes. So here you are, let's say you say print sentence.count, and then you give your A, which is what you want to count, and then comma 10, that is from 10th position onwards, how many times A comes. So let's go back to our string here and let's see what is the 10th position here. So we're looking at this substring and we're looking at how many times A comes. So here in this case, 1, 2, and 3 is what is the number of times A comes here. So let's see. And you get a value of 3, which is what we had calculated, right? So let's say now you want to know what is the position from which your first occurrence of remains begins in your string, right? So for that, the command is find, right? And find is again used the same way as lower, upper, and count, dot find. And then in the arguments to find, you can define what is the term you want to know. You mention the word or a letter whose first occurrence in the string you want to know, and you want to know the index of the first occurrence. So remember, the indexing begins at 0 and gets incremented by +1 for every character that is present in the string. So here you are. Let's see first where remains comes for the first time. So if you see here, this is where your remains is coming, right? So we need to calculate the number of letters that are here, right? So this is 0, 1, 2. Remember 0 indexing. So the first character is at 0 place. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and R begins at 9 in that case, right? So when you take 0 indexing, R begins at 9. So our answer to this should be 9. And your answer is 9, right? So this is basically to tell you that Python has 0 indexing, its strings. The first character began at 0 place, and the next one at 1, the next one at 2, and until n. So this gives you the position of the first occurrence of the remains in your sentence. And remember, there are 2 remains. So now let's say you want to also know the beginning index of the last occurrence of the word in the sentence. So for that, you say rfind. So this is reverse find. So this will start from the back end and give you the last occurrence of your word that you want to look at or the letter that you want to look for, right? So here you are. Let's say you say print, and then again you say sentence.rfind. So, and then in the round brackets, you give within the double quotes the word or the pattern that you want to search for in your string, and then you close all your brackets. So when you run this here, so let's say what should we get here? Right? So remember, R was 9. So this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I think it should be 25. Let's see what we get here. So we run this now. 25 is correct, right? So this was basically to find the last occurrence in a string of the words you are interested in or the letter you are interested in, right? Let's say you want to look for a word that is not found in the string. For example, let's say you say sentence.find and you're looking for a song. So in this case, what you'll get is a -1 value because it is not present in your sentence. So this gives you a value of -1. So let's say you want to remove a part of your string from the end. So you can specify what is the specific word that you want to remove within an argument to R strip. So R means from reverse or from the other end, R strip, and then let's say we want to remove AINS, right? And then of course you say print sentence.R strip AINS, and you take care that all the brackets are closed. When you run this now, what you get as the remaining sentences, all that remains is what? Rem, because AINS is now lost. So let me just give an alternate here. So let's say remain remains equals to, right? Sentence dot or strict, and then I give AINS, right? And then in the next statement, I say print, and I say print remains, right? So this is another way of doing it. We first transfer the value that is generated by the command to a certain variable, and then print that variable. So here you are. If you run this now, you should get 2 times the same statement. All that remains is what? Rem. Right? So here you are. This is from this first top statement here, right? And this is the same thing where first you equate it to a variable, the actual command output, and then you print that variable in the second sentence. So both sentences are fine. If you want to use the output to next process in the program, then of course you have to equate it to a variable. If you just wanted to print, you can directly print. So that is up to the requirements of your program. Let's take another example, and this time let's take a biological example. So let's say DNA is equal to an AATTGGCCAA. So you run this. So DNA now carries the sequence AATTGGCCAA. First, of course, you can print the length of the DNA. So this is simple. You say print, and then within the print, you give len DNA, and you close all your brackets here. So when you run this here, you get the length of your DNA, and you know it is going to be 10 because the 4 nucleotides come twice, and then A comes one more time, twice over, right? So this is your 10 here. Then let's say you want to count the number of times A has come. So again, the pattern is the same. You say DNA.count, and then in the argument to count, you specify what is the letter you're looking for. So in this case, you're looking for A, which is to be given in double quotes. And then you keep the entire statement within the print statement so that you can finally print your the number of times A comes in your sequence. This would be 4 because you have A at the start and double A at the end, right? So this is 4, which is correct. Then you could find the first occurrence of A. So first occurrence of A would be at this 0th position. So if you say this, print DNA.find, the argument to find is A. So when you run this, this is going to give you the first appearance, the index of the first appearance of A in the string, which is going to be 0, right? So because in Python, strings are 0 indexed. Remember that in Python, strings are 0 indexed. Likewise, you want to check the last appearance of A so that the index would be basically, in this case, it would be 9 because the length of the string is 10. So if you run this again from the other end, so this is going to be 9, right? Because you start with the index of 0. So this is your 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the last occurrence of A, which is what you find by rfind, is at 9th position in this string, right? So let me add a code here and print the DNA one more time so that we have a ready reference. So print DNA, and you run this here, and you have your sequence in front of you. So this is your sequence AATTGGCCAA, right? Now let's say you want to access individual positions or subset your string into a smaller string. So the way you do that is what is known as the slice command, right? And slice command can be used to access individual positions in a string or a group of positions in a string which are contiguous to each other or continuous to each other, right? So let's run a series of commands and see what is the output and analyze how the output has come. So you say print, and then in double inverted commas, you say DNA0 colon, and then with the comma, you say DNA0. So this is going to give you the value of the nucleotide that is present at 0th index in the sequence, which is going to be A. And this is going to be printed as such because it is in double quotes. So this gets printed as such. This gives you the index of where you're looking at, and this gives you the output of what actually comes from your string, right? So this is one. Then you could also use the splice command in a second format. That is where you can define your two numbers with separated by a colon, right? So this is 0, DNA 0, colon 5, right? So now what does this mean? This means that you're looking at a substring starting at position 0, and then you're looking for until position 4, right? So you're looking until position 4. So 5 means it will move until position 4 and pull out that substring and give it to you. 0 is to 8 means it is starting from 0 and basically pulling out a string from 0 until the 7th position. 2 to 5 means from position 2 until position 4, whatever stretches there, that is going to be pulled out and printed. So let's run this and analyze the results one more time. So here you are. If you see DNA 0 equals to A. So this was your first command, DNA 0. And basically you're looking at the 0th index in this string, which just happens to be an A, right? Then the second one, 0 is to 5. You're looking at position 0, 1, 2, 3, and 4. So what you should get is AATTG. If you see here, you get AATTG. So when you say 0 is to 5, you're printing from position 0 until one position short. That is from position 0 to position 4. Likewise, when you say 0 is to 8, you are starting from position 0 and pulling out a substring until position 7. So if you see here, this will be 0, 1, 2, 3, 4, 5, 6, 7. So this is what you're going to pull out. This is going to be AATTGGCC. If you see here, you have AATTGGCC. Now let's look at 2 is to 5. So 2 is to 5 is you're starting at position 2 and then you're pulling out until position 4. So 2 is to 5 is 0, 1, 2. So you're starting at this T. Right? You're starting at this T, 2, 3, and 4, right? So you are stopping at the 4th index. So this is basically your TTG, right? So when you write a notation, X is to Y, you're starting at position X and stopping at one short of position Y, right? X is to Y means starting from position X, extract the substring until Y minus 1 position. Right? Now let's talk of another function for strings that is known as concatenate. So you initialize the second DNA, DNA2 is equal to, and in double inverted commas, you give 4 times A. So this is AAAA, right? And then you say DNA3 is equal to DNA, which is our original sequence, AATTGGCCAA plus DNA2. And then the other way around, you say DNA4 is equal to DNA2 plus DNA, right? So what this is going to do is to join the two strings together, and the order of strings will be the way it is mentioned in the plus statement. So here in this case, it will be the AATTGGCC, AA string first, and then the 4 A's second time. And here in this case, it will be 4 A's first, and then followed by AATTGGCC, AA. So here you are, print DNA3, and then a comma, and then DNA3, right? And likewise, print DNA4, which is in double inverted commas, so which means it is just getting printed as such. So next you print DNA4, and this is within double quotes and will be printed as such. Then you give a comma and then you give the variable name that you want to print, which is DNA4. So let's run this out and see what you get. So here you are. So here you are, you have the first string, which is DNA, and then this is concatenated to the second string, that is AAAA, right? So this is what you have. Likewise, for the second one, where you use DNA2 first. So this string begins with first the 4 A's, which is your DNA2, and then the remaining string, that is AATTGGCCAA, right? So this is how you concatenate, and in concatenation or addition of strings together, A plus B is not the same as B plus A. So the sequence of strings, how they attach, changes, right? So that is again something that is important and must be remembered, right? So let's say we want the same string multiple times in a single string. So you could do that by using the asterisk notation. You say DNA5 is equal to DNA2 asterisk 2, right? And let's also print this out. So you say print DNA 5, right? And let's now run this part here. So you run this, and what you'll get is now twice the size of the string of the original DNA 2. So this is AAAA. This was the original DNA, and now it is basically AAAA again, right? You could make it, let's say, 5 times. So you could do 5, and you could say run again, and now you'll get it 5 times. You can calculate the length of the string. So you can say print len, and now you're printing the length of DNA 5, right? And remember, now DNA 5 has 5 copies of DNA 2. So each copy is 4 nucleotides, 4A, which is now 4 into 5, that is 20. So the length that you should get is 20. You can run it again. So when you run this here, you get the length of 20, right? So we have discussed a few functions that can be used in string operations. We have used lowercase, uppercase. So lower, upper, find. Then we have used count. And then we've also used the asterisk and concatenation to show how strings can be operated upon in Python. And in the next lecture, we start with the more complex data structures in Python. We start with list first, and then we move on to tuples, and then we move on to dictionaries, right? Thank you.